So, deposit modelling, creating a geoarchaeological cross-section. For the learning objectives, the aim of this session is to provide a brief background to deposit modelling and the processes involved in creating a subsurface cross-section. Hopefully by the end of the session, you'll have a greater understanding of how to research the geology of the site, how to interpret geotechnical sediment data in a geoarchaeological context, how to create a subsurface cross-section for a site, and how to carry out a geoarchaeological assessment for a ground investigation. So we can learn about past environments by studying the sediments beneath the ground. Typically, the oldest sediments will be at the bottom and new sediments are deposited above, kind of like a layer cake, getting younger as the depositional sequence profile goes upwards. Deposits preserve archaeology better than others if it's present. It can be found in any sediment type. However, some environmental conditions may increase the likelihood of survival. Then how can we reach the sediments at depth? One method is through borehole surveys. Using the sediment data gathered from the boreholes, we can identify deposits with geoarchaeological potential through deposit modelling. The types of outputs that we would typically produce are digital elevation models. Thickness plots are also an output that we can create, and subsurface transects, so cross sections. So I've come up with, I've printed you out all some different worksheets as well. We can work together on this, but don't worry if it's not one. What do you notice? What do you notice about the geology of the area? Does it show any features?
It's all based on the river itself.
Yeah.
River Avon. The river terrace deposits is obviously a former location of the river, a recent former location, I guess. The alluvium is obviously from being next to the river.
Yeah. What types of sediments or deposits are you expecting to be there? So if you haven't been to site yet, or you haven't, seen the logs, what type of deposits do you think would be there?
So with the alluvial deposits, you're looking at silts, clays, probably of variation of probably high energy and low energy. So you'll be expecting fine gravels and larger gravels if it's potentially higher, especially with river terrace deposits as well.
Yeah.
So looking at probably, it's just a lot of wet. It's wet deposit, isn't it? It's wet deposit. So you could look at kind of probably oxidized stuff if there was, or iron oxides and all that things. So
any other things that you might expect?
Some gravels, potentially, especially in the river terrace deposits. All clays also associated with that, so at the top boundary of the river terrace deposits.
Yeah, definitely. There could also be waterlogged or organic inclusions as well, because it's within a riverine environment. So there could have been plants growing on the riverbanks or organic matter forming as well. So yeah, typical deposits of an alluvial sequence. So silts, clays, sands, gravels, fluvially transported sediments. Okay, so that's task one. I think I put a box to fill in just to jot some bits in task one. So I don't know if you wanted to put your initial, what you're expecting what the geology is and what you're expecting to find. So for task two, it's looking at the borehole logs themselves. So I've provided some example sediment descriptions within a table. So you've already got the borehole ID name, the depth, and some geoarchaeological sediment descriptions for that deposit. And so the next step would be whether you've taken you've written those descriptions in the field yourself, or you've received the logs from the engineer. The first task you'd have to do back in the office would be to interpret those into stratigraphical units across the site. Yeah, any initial thoughts on?
Probably topsoil with this dark brown sandy slaty clay, with lots of rooting throughout.
Yeah,
Would guess a topsoil.
definitely. And I think when you kind of start identifying some of the deposits within a site, you can then straight away assign other ones to that same thing. So if you see other ones of like frequent rooting throughout at the top, very top of the borehole, you can think, okay, that's likely topsoil associated.
Yeah,
Yeah, so that would be the first kind of stratigraphical unit.
I mean, the light brownish grey soft silty clay that seems to be in all of them is likely alluvial. I would guess the charcoal flecks are either from the London clay deposit bedrock, which I believe can contain charcoal flecks, or they've just washed in from sort of human interaction nearby.
Yeah, exactly. So you'll have mixtures. There might be some that are silty clays, there might be some that are clay silts, some that have a bit of sand content. But yeah, again, this is to show that alluvium, the term alluvium can be assigned to many different variations of of those deposits.
It's like a light brownish grey from clay silty sand. So it's not gravels, it's not. But that's different to all the other, I believe, other sediments in here. So that looks like
What would you what would your thought process be with trying to interpret something like that that's perhaps quite localized or a bit different to other descriptions?
so if it's 6 meters, if it's 6 meters down, it looks like there may have been a something to do with the river. Probably.
Yeah.
No, this is good. I've put, there's a few little kind of.
It's like a slow energy. There's not a lot of. It's fine to medium sands throughout. There's not a lot of. There's not a lot of inclusions.
Would it be like a river beach kind of situation?
Yeah, like a.
Because it's also in number 5, the same.
Oh, is it? Oh, don't
Yeah.
worry.
No, they're the only two.
Yeah, there's it's
Well,
not mentioned in all of them.
Number 4 has a similar but less sandy deposit. Okay. But it's softer. But yeah. There's seemingly more charcoal being washed in,
Or it's just
or
travelled. It's
Yeah.
just travelled, but like a low travelled. Or it's just a set gravel in that way, set sands
Yeah, like
where it's travelled in,
yeah, maybe.
or whether it's stopped. Maybe I don't know.
Yeah.
I need to read my
That's
books.
fine. Maybe it's still alluvium, but it's faster paced, I guess.
Yeah,
Exactly. So it's not a terrace deposit. It doesn't have those same characteristics of the gravel,
Mhm.
the kind of coarse gravel, class supported river terrace deposits. So
Mm.
if you're going to be modelling the upper surface of the river terrace topography, it's important to know those boundaries and the changes in between.
yeah,
So that would not sit in with a river terrace deposit. It's an alluvial deposit. It is different to the other alluvium recorded. So well done picking up on that. But alluvium is silts, sands, clays. You can have gravel content as well.
yeah.
It might just be that, as Adam said, it's a more kind of fast and flowing part of the channel where that's been deposited. So should we start looking at some of the interpretation? Yes.
Yeah.
Okay, so for borehole 1, I've got topsoil, overlying alluvium, overlying river terrace deposits, overlying bedrock. So for the site, this is the sequence. This is the general sequence that is encountered across the site. We've got these 4 deposits, varying thicknesses, but that's pretty much what is there. So did everyone kind of get that? Yeah. Okay, so task 3. So now you've completed a geoarchaeological interpretation of the geotechnical sediment data. Draw the upper and lower boundaries of each unit onto the blank cross section shown on figure 2 to map the subsurface deposits beneath the site. Once you've put all of the boundaries on, without joining them up, like you kind of started to do, and having a think about what features, can you see any features represented in the landscape from the cross section? And other deposits that you've mapped typical of those types of features that you'd expect to see.
Get them on the lower boundaries. Or...
Both. Well, so you connect the tops and the bottoms. So the top of all the topsoil will be linked, and the bottom of all the topsoil will be linked, and then the same for alluvium. So naturally, that line will already be in place for the top of the alluvium if you've got the bottom of the topsoil, and then you draw the line connecting the bottom of the alluvium across. That makes sense.
Yeah.
How is this looking? Is it looking like it makes sense?
It's a bit slight mistake where I somehow
Fine.
mixed up my own key.
It's confusing, isn't it?
Yeah. But it's making some sense, sort of, if you ignore the scribbles.
You've essentially got topsoil overlying an alluvial deposit that gets thicker towards the location of the river, and river terrace deposits, which are on either side of the river location, and then bedrock underlying the whole sequence. So,
That side being steeper and that side being shallower and more liable for flooding.
yeah, exactly. I think typically if you've got a river, if your site's near a river and BGS maps that there's alluvium and river terrace deposits, it's a great start. You know,
Yeah.
This is what we're likely to expect. So you can already go in with the knowledge, knowing, okay, I know what should be here, and then you look at the data and see does that match. So for task 4, what features do you note?
Yeah, they were exactly what we sort of expected to find at the beginning. You obviously mentioned we could do further sampling on the peat, maybe even the organic alluvium that we sort of encountered.
Yeah.
We obviously noticed that right like adjacent to the current location of the river, there's the most alluvium. Biggest, yeah. Yeah. Sort of expected.
Yes.
It's quite a typical sequence.
Yeah. That's what we like to see. Obviously, if there were deposits there that weren't typical or varied across the site, then it could indicate that there's a more complex stratigraphy or it's a more dynamic environment. Maybe it's more of a braided river channel system, and there could be more localized deposits or different speeds of water flowing through the area, or it might be more complicated than just one river channel going through and the sequence that we've got here. But the good thing with this is that it's getting you to ask and answer questions. So I don't mean just in this exercise, I mean in general, when just looking at deposits from the site, you're kind of trying to think, does this make sense? Is this fitting for the location? Does it correlate to what's previously known, or what I was expecting? Or does it show something different? Does it enhance understanding, or does it show something that we weren't expecting? And that's not a bad thing either, because it's more data, it's more information, and it might be more interesting, an area of significance that we might want to explore further. So it's not always a bad thing if it doesn't match, but if it does match, then that's
It's good, yeah.
So looking at the deposits here, what deposits have likely geoarchaeological potential?
So well, peat,
Yeah,
yeah, peat and organic alluvial, because
Yeah.
we've got a lot of preservation, which can take to the environmental department. Um,
Upper river terraces.
yeah. Yeah, so knowing that upper surface, you can think, okay, in the past, how may humans have interacted with the landscape? Would they have been active, or would there be settlements or fish traps, or different types of archaeological activity happening on the edges of the river? So knowing where those boundaries are, or where it could be a paleo channel that's silted up. So knowing where those banks were previously, we can think, okay, if archaeology is present, there's a good chance it could be along the banks of the former river. Yeah, peat and organic alluvium are good for environmental indicators. So lots of dating and further environmental analysis, building up a better picture of the environment, the types of plants, trees, vegetation, that kind of thing. Alluvium in itself typically has a low geoarchaeological potential, although it can seal archaeology. So if archaeology is present, there's a good chance there'll be really good preservation of it within the alluvium. However, because its depositional nature is that it's washed in sediment, often you might find the odd pottery sherd or inclusion, but it's likely to be out of context. It washed in, it would have been from another site. There's not really much other than you could have it dated or looked at by a specialist, but other than
Even
kind of
then, that won't tell you much
No.
about that exact spot.
No. so alluvium, although we kind of like look for alluvial deposits, alluvium in itself typically has a low geoarchaeological potential. However, yeah, things like organic alluvium and peat that could be within the alluvial sequence have a higher geoarchaeological potential.
Okay.
So what would your recommend? Would you have any recommendations for this site? What would, in terms of next steps? You've gone out to site, you've monitored the borehole drilling, you've collected the data, you've put it into tables, and then you put it into deposit modelling software, created your Transact. So what would your kind of summary of these deposits be?
In a sense of what they tell us, or in a sense of what we think we could gain out of them in the future?
Bit of both. So like, are they, what do they tell us about the site location?
Mhm.
Are they, are they typical what we're expecting to find? And then are there localized areas that we could recommend further work on?
well, the localised peat,
Yeah.
Yeah,
potential organic alluvial, because that
Yeah.
may have either archaeological or environmental indicators.
yeah,
I guess it also shows that it's the locations adjacent to the river, outside of the alluvium, right next to them. Clearly, you had lots of plants growing there.
yeah,
It was clearly built up, like a forest. I don't know what to say. The plant life is just sort of, it's very organic, between 4 and 7.
yeah. So on the banks of the, either side adjacent to the channel itself,
Yeah.
there, there's evidence for vegetation. Obviously, if a environmental specialist looked at those, then we could kind of ascertain, are they reeds? Are they, what type of plant are they? Is that useful? Was that?
Yeah, that's really useful, yeah.
Therapeutic colouring in.
Yeah. So hopefully, the learning outcomes of the session, hopefully you'll have a clearer understanding of how to research the geology of a site, how to interpret geotechnical sediment data in a geoarchaeological context. So when we were going through interpreting all of the lithological data into that stratigraphy column, that's geoarchaeological assessment. how to create a subsurface cross-section. Although this is in paper form, it's the same theory. Understanding the process means that you can do it within the software. If you know what you're trying to achieve, then you can do that. How to carry out a geoarchaeological assessment for a ground investigation. So hopefully that's been really useful for you all and gives you just a better idea of the processes involved in, you know, how we then transform that data into the deposit model and the things that we're looking for.
That's cool.
Yeah, does that make sense? Yeah, is there any questions or all good?
Can't think of any.
Yeah.
Can we have more of those borehole pin plays just so we can colour in?
Absolutely.
Colouring book, yeah.
It's therapeutic.
It's a nice Friday afternoon. Yeah.
Just get one of the reports, just go la, 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 like on the weekend, like.
Yeah.